Right, this is part 4 of the accumulation function fundamental theorem of calculus packet. We have now h is a function given by h of x is equal to the integral from x to negative 3 of f of t dt. Now we are working with x being 1, we're working with negative 5, negative 2, positive 2, and positive 8 in just a few minutes. So what we're going to do is this. If the value of x we're working with is less than negative 3, we're going to go ahead and leave the bounds the way they are, but that only matters down here when x is negative 5. For all the other values, we're dealing with a bound that's greater than negative 3. So what we're going to do is we'll say that this is equal to the negative, or the opposite of the integral from negative 3 to x of f of t dt. Which means when x is greater than negative 3, we can just find the area from negative 3 to that value, and then just we'll negate that. Okay? So let's start with h of 1. Again, since 1 is greater than negative 3, we're going to take the area from negative 3 to 1 of f of t dt and then negate it. So let's see here, from negative 3 to positive 1, so from negative 3 to positive 1, we have a strange area here to do on its own. So we're going to split it up instead into 3 sections. We'll take one section from negative 3 to negative 2. That's a triangle. We'll take the area from negative 2 to 0, and then the area from 0 to 1. These two would be trapezoids. So we end up getting here, we'll take the negative, and we have a triangle, so it's going to be 1/2. The base is 1, the height is 2, plus we have here a trapezoid, so it's going to be 1/2. The height is positive 2, or the height is 2. One base is 2, the other base is 1. So it's half the height times the sum of the bases. And then we have here another trapezoid. So it's going to be 1/2 the height, which is 1, and the bases here are 1 and 2 as well. So up here, 1/2 times 1 is 1/2, times 2 is 1. Plus, in this trapezoid, the half and the 2 will cancel, so 2 plus 1 is 3. Plus, here 1/2 times 1 is 1/2, 1 plus 2 is 3, 3 times 1/2 is 3/2. So I get 1 plus 3 is 4, which is 8/2, plus 3/2 is 11/2 for h of 1. For h prime of 1, well again, h prime is just going to be f evaluated at 1, and f of 1 is positive 2. And then h double prime of 1 is the slope of the graph at 1. And again, this is linear, so y2 minus y1 is 2, x2 minus x1 is also 2, so we get a slope of positive 1. Now here we have to place the following in order from least to greatest. So we have h of negative 5, we have h of negative 2, we have h of positive 2, and we have h of 8. So let's start with h of negative 5. And again, because this is less than negative 3, we can just use this up here to say that would be the integral from negative 5 to negative 3 of f of t dt. So the integral from negative 5 to negative 3 is going to be, well, it's the area of this triangle. But because it's below the x-axis, it's going to be negative. And the area is going to be 1/2 times the base, which is 2, times the height, which is 4. Half of 2 is 1, and I get negative 4 for the area. For h of negative 2, we are working with the integral from from 2 to negative 3, negative 2 to negative 3 of f of t. Again, because this bound is smaller than this one, I'm going to negate the area from negative 3 to negative 2 of f of t dt. So from negative 3 to negative 2, we actually already found this area to be up here. The area is 1/2 times 1 times 2, or 1. So the area from negative 3 to negative 2 is positive 1, and so we are negating that, so the area would be negative 1. Next, h of positive 2. Well, again, so this would be negative the area from negative 3 to positive 2 of f of t dt. So we're taking the area from negative 3 all the way out to positive 2, and we will negate it. Now, up here, we already found the area from negative 3 to positive 1. That came out to be 11/2, which we then negated. So I'm going to take that 11/2 and add on to that just this section right here, the area from 1 to 2. So that's a trapezoid, so 1/2. The height is positive 1. The bases are positive 2 and positive 3. Two plus 3 is 5, times 1 is 5, times 1/2 is 5/2. So that gives me negative 16/2, or negative 8. And finally, we need h of 8. So we're going to take, again, because this is bigger than negative 3, negative the area from negative 3 to positive 8 of f of t dt. Okay, so negative. We already know the area from negative 3 all the way to positive 2 is negative 8, is 8. The area from negative 3 to positive 2 is 8. And then what I need to do is then look at the area from positive 2 to positive 8. Well, one thing you can do is notice that this section right here and this section right here are congruent. They both are triangles with a base of 3 and a height of 3. This area would be positive, this area would be negative, so they will cancel each other right out. So we actually don't accumulate it. We don't pick up any additional area from positive 2 if we go all the way to positive 8. So we can go ahead and just say that that piece is 0. So I get negative 8. So the question says to place the following in order from least to greatest. So we can say in both of these cases I have h of 8 is actually equal to h of 2, which is less than h of negative 5, which is less than h of negative 2. Okay. And that would be the answer to that question.